All right, welcome to the build. So it's moving quickly.
And their product velocity is intense. We're both pretty involved in the LangChain community.
This is going to be an industry, like the whole thing is going to explode.
The hype cycle, it's like just because you hear everybody start talking about these things doesn't necessarily mean it's the right.
Need to go back, find out more because it's really interesting.
We're both obsessed with AI and their entire stack is just pivoted to agents.
The next question that usually comes after that is like, well, I'm fine-tuning an open model.
That's the biggest thing with the latest specs.
An exploding distribution vector.
I'm really excited. I think everybody is. I'm not the only one.
The build. How's your week been?
Yeah, it was sick, man. I went fishing and tracked. Yeah, I think I'm a fisherman now. As in, like, sorry, let me rephrase. I think I've caught the fishing bug.
The bug?
Yeah, I think I want to get into fly fishing, you know? It kind of looks, I realize I'm now just an old man.
I think that's probably the tell right there. Hey, my passion is now fly fishing. Where did you go fishing at?
The Qwen River, which is up in like Sierra Nevada, like central California, basically. And
Nice.
it's rad, man. Like, it's so good. Like, just hike up these rivers. There's like, you know, like sandy beaches and stuff on each, like, turn in the river. I was there with my son. So, you know, we were going and doing some, like, you know, band time. And he's 12 and it's time to, like, get him out there and, you know,
Playing in the
having,
woods?
yeah, start having some chats.
Oh, nice. That's awesome.
But yeah, it was great. And then we're just eating, like, basically we just survived off jerky for the whole weekend, which is pretty funny. But I think, to be honest, I didn't really know what I was doing. So I think probably the right strategy probably wasn't squealing like a little girl and going, yeah. But as soon as I pulled it, like, the whole thing snapped, and it just, like, I literally saw it just, like, snap the line and then, like, stay in the water and, like, just wasn't even scared of me. So
But yeah, our weekend was good. We spent time in Houston. My family was in town. And the main thing that we did is went to the Houston Space Center, which was really cool.
that'd be awesome.
Yeah, pretty inspiring, amazing. I mean, of course, seeing a lot of things like that, but it's so many things put it in their perspective, man. Like one of the items that was on display was a little calculator, and it just said, like, this was the backup navigation system. Like, literally a like a TI
That's amazing.
programmable calculator. And it's those things that really put it into perspective. And trying to explain, sound like an old man, like, to these kids, and your iPhone, your iPad are like 100 times plus more powerful than how they got to the moon.
Go to the moon, yeah.
Yeah.
I took that's so awesome. I should go there. I took my kids to this Air and Space Museum in Washington when I was there last year. And that's similar. Like they had all of the Voyager space probe, Voyager 1 and Voyager 2 things. I'm not sure if you remember those, like, from when I was young. It's just like that era, that NASA kind of, like, space exploration era, you know, and they had a bunch of the moon landing stuff as well. It's so inspiring. It's so inspiring. And it was really like that American exceptionalism kind of era.
Yeah.
And, like, as soon as I got out, I was just like, this is the most amazing. Like, this is just what they achieved through that period was just incredible. And so I got out. I said to my kids, just whatever you want to buy in the gift shop, let's just buy as much NASA shit as we can.
That was us too. And it was actually a cool gift shop. But yeah, man, like, the bravery, I don't know. Even if you really, really appreciate it, I think it's still like, we can't even imagine the bravery of those first guys that were like, yeah, shoot me up and I'll take a step out. I mean, it's all like mechanical and analog, everything. Like, even the console, you see all the people at the space station, like, in the big room. I was looking at the console buttons, and they have, like, you know, one button does something very, very specifically. And it's just a bunch of people. So different than how computers work today.
Well, it's
Anyways.
literally a button. It's like, all right, start oxygen.
Yeah, exactly. Like,
Right.
but one button dedicated to that. That's somebody's control area. But yeah, this is not a space podcast.
So, Cameron, episode 9 of the build. What have you been seeing that caught your eye this week?
Yeah, well, we are going to do a little bit of a crossover from last week on the vector embeddings and GraphRAG. but I know you have a couple items that I'm particularly interested in, like we just the JSON for Veo, and I guess that really applies to video and image generation models in general, maybe not necessarily Veo.
Yeah,
And then I have
I
some
think
security items which we'll naturally hit on through the conversation. So I think as far as news and some of the um, headlines, I think you have a little bit more background on those items.
yeah, I'm going to go first on a couple of them. So the first thing I wanted to mention is Qwen. There's a couple of like Qwen3 Coder came out this week. So we covered Kimi last week, and it seems just like the Chinese labs are just going for it and releasing these models. The details like it's a slightly smaller model than Kimi 2, but it's designed effectively for coding, and a couple of like it's pretty similar, some similar tactics to how they built it as the Kimi model, which we covered last time. But it's open source, and they are claiming on some of the benchmarks that it's just as good as Claude Sonnet 4, which is amazing. One of the things that I saw in some of the documentation is that 70% of the tokens, about 15 trillion tokens that they trained on, 70% of those tokens were code related. And the rest, the last 30% was like general information, also like, you know, specific kind of logic, math, all that sort of stuff. So that's really cool. And then they have this, you know, agentic tool use kind of focus as well. So it seems like all the models are going there. So that's really cool. There's also a CLI that I got running, so I'm going to start testing that this week. So they've actually released a fork of the Gemini CLI, and they have instructions on their documentation where you can actually go through and configure it in the router for Claude Code as well. So I'm going to play with that this week to see if I can. I've got a specific task I built this week with Claude Code. I'm going to see if it can actually execute on that rather than just 3JS models of like the world models and shit.
That's fun.
So
though.
that was that was really cool.
You're talking about using Gemini CLI and Claude Code, the CLI tools powered by Qwen3 as the LLM.
Yeah. So it's it basically it's just a fork of the Gemini CLI is the one that they recommend. So it has all of the same like commands and functions and stuff. And then I rigged it up with the Alibaba Cloud API providing tool, which is actually excellent. Like I'd never used it before. I'd never really had a reason to go down the Alibaba Cloud kind of path. But yeah, super excited to jump into that. The specific thing I wanted to show you was the boost in performance. So if I show you that here.
Yeah, and as far as the code specific model, Qwen has been doing that as far as I know from the beginning, like 2.5. Some of the earlier ones, the code models were fantastic.
Yeah, they were. So they had Qwen Coder, Qwen2 Coder. So this is like Qwen3, right? And then they had Qwen3 235B, amazing model names. On this is SWE bench verified performance. And you can see it's up there with Kimi 2 and then also Claude Sonnet. Claude Sonnet. And I think this 500 turns definition, I believe, is like multiple attempts. I'm not exactly sure. But you can see the performance boost over DeepSeek. Interestingly, I wonder when we'll see the next DeepSeek model come out. But it looks pretty amazing and it's pretty cheap, which is great. So, I don't know. I love the velocity that these open source models are coming out with now. It's great.
Yeah, definitely.
Yeah, I don't know, you're a Qwen user. Maybe you could get it running in Qwen for me and tell me what it's like.
Yeah, well, is it on Open Router or just directly through the Alibaba?
That's how I got it running, was the Alibaba API. Super easy to get moving, so yeah, I'm going to try it out through there.
Looks like they have it on Open Router.
Yeah, cool.
So
I saw another. But related to this, so of how these are trained. So OpenAI launched their agent this week. Did you see that?
I did. I I was with my family this week, so hadn't had a lot of time to play. But last night I gave it a spin, and I'll be honest, it was like a little bit like whatever. They put out these new things, and do these. You can already do this with like open source tools and stuff. But after playing with it for a little bit, I was like, yeah, it's pretty good.
Yeah. So I think because I haven't played with it, probably for the reason you're describing, because like we're pretty already used to using kind of tools like that. It sounds like it's basically a mashup of operator and deep research, right? That's sort of
Yeah.
what the product is. But what I think is cool is when OpenAI comes in, they've got that product nuance, and they come in and they really kind of execute from a product sense on these agentic kind of experience as well. That, and they have the distribution, so they can distribute it to 700 million daily active users, or however many are still in the platform every day. What I found interesting, which is similar to Qwen Coder, is that they actually specifically mentioned that they had a reinforcement learning environment where they actually just put it into these virtual containers and actually just got it to go through the motions of like trying to execute on tasks. And then they had a reinforcement learning loop, which is exactly how the Alibaba guys optimized their Qwen3 Coder product. They said that they basically just pointed a bunch of cloud infrastructure and spun up all these virtual containers and had it training in this virtualized environment, which is also how Qwen3 was built for these agentic kind of apps. So there must be like a custom model behind the scenes. So it sounds like that's like the new standard for trying to build agentic experiences within these models.
Yeah. I think you've probably read more about it at this point than I have, but I think the big takeaway there, or like the revolutionary concept that they're pioneering, is the combination of like the computer vision models plus like web scraping and all these other ways to like deep research, but they're using a combination of computer vision and your just like text-based crawls.
Yeah.
And
Yeah, they give it both. They're basically like, they give it a vision experience and then they give it the text-based experience. Plus then there's a virtual browser that it can use and interact with. And it has a Python environment it can spin up and do data analysis.
Which is really powerful. I've mentioned I was really hot on the computer use, like Anthropic computer use came out months ago, got really amped up and kind of went down that hole for a while. But Microsoft also had I'm blanking on the name, but I think we even talked about it one day here.
Yeah, I can't remember the name either.
they had a open source project that was specifically focused on training computer vision and the way that it coordinated the pixels and things like that. And I think now I'm going to have to find it because it doesn't really help that I'm like, this thing is out there. But I feel
There's
like
a lot of them though. There's a lot of them out there.
yeah, I feel like that concept, that's a good indicator that you're right on the custom models and custom training for computer use or vision specifically.
Well, that's interesting. It's a good segue to the next thing that happened this week, because it seems like that's what these labs are pushing towards, specifically on enabling the models to use tools well, right? There's some sort of reinforcement learning pattern that has to be applied into the tool arena. But on the flip side this week, so DeepMind and OpenAI both submitted AI competitors into the Math Olympiad, which was pretty cool. And they both got a gold medal, which basically means they scored 35 out of 42, which means that they solved 5 out of 6 of the problems. The Math Olympiad's like the Olympics, the Youth Olympics for maths. So it's like there's certain qualification criteria for math geniuses to go into this thing. What's interesting is that a lot of the people who observed the progress on AI models said that we were at least a year, if not more, away from any model being able to get that level of performance in the Math Olympiad. Which is interesting. So the pace of performance is like accelerating faster than people originally thought. Number 2 is that the way that actually Frontier Labs, say in this case Google DeepMind, approached this problem in the past is that they had some specific models that were designed around this task. So they had specific models, and then they had a specific approach to get to optimize into providing math proofs for these problems. But these two models, so there was a custom defined one that OpenAI had, and there was a basically an extended version of Gemini. It seems they didn't talk a great deal about it from what I could find anyway. Were generalist models, so they weren't specifically trained on this. They were generalized intelligence models that were and then they basically applied those general models to this Math Olympiad, and it performed within the time period, so 4.5 hours, similar to humans. So on this end, it's like bucking that trend. They're like they're general kind of intelligence models as well. And the reason why I thought it was interesting to talk about is these are abstract math problems. And I was like, well, what does that actually mean? Like, what does that actually mean for us? What can we expect? What happens with these like theoretical maths, right? It's very abstract. It's very esoteric. What typically happens is they'll discover or new math proofs, or like they'll make a breakthrough in a certain area of maths. And then it's generally a very long time between that and an actual product outcome that you and I would recognize. Like a really long time, right? So what I wanted to try and understand is like, well, what are the examples? What are examples of where there was a math proof and a math kind of breakthrough? And then when did we see like an applied engineering outcome from some of those things? So a good example is probably general relativity, right? That was Einstein building on some like other breakthroughs in maths prior to him. And that was like 100 years ago. And that was the basis of the applied engineering outcomes for things like GPS or accurate clocks that can effectively maintain time. So, but that was like, what's that, like maybe 80 years between that point and like the actual execution. With this breakthrough, I think the thing that is exciting is if AI can be applied to these really challenging fundamental math problems soon, that time period should be truncated and should be dramatically reduced down, which is really exciting. So if you want to have fun with this, just go to Veo3 or like Gemini or whatever and just put in like, what are the outstanding math problems that if they're solved, what are some of the things that could be developed? And so AlphaFold is a great example of that, right? Which is like basically mapping all of the protein, like the protein folding solution that effectively enables scientists to more effectively understand all the various proteins. But the effective outcome of that is the promise is basically just like really, really rapid drug design and delivery, like turning that from a multi-decade process to like a year, 2 years, whatever. Like you can imagine the world that what that would look like and the world that we would live in if that really did come to pass. So that's why I think it's exciting and worth talking about.
Yeah, absolutely. The big thing is around, or in terms of time frame, you're talking about how it took 80 years, 100 years, several decades, for the innovation in these areas. But now we're talking about LLMs and reasoning models that will be able to come up with new ideas, right? That's what we're shooting for, and some people say we're already there, and that is going to be exponentially different than it was in the past. Because like I always think about the story when people say, what was it, refrigeration came out, and then people didn't really know what to do with it, and it took a long time for all these different like Coca-Cola and whatever else products to pop up and be like, oh, we can use this to our advantage. AI is kind of the same. But if we have the AI capable of helping us generate, be innovative and come up with new ideas, that time frame is going to drastically.
It's potentially more expansive, right, than any other technology that we've ever experienced. Because so the analogy that a lot of people use is electricity, right? And it's amazing that we still have like the basic execution of electricity in our homes, which is a light bulb, basically just putting electricity through a little filament and then it flashing, replacing a candle or like a gas lamp. But when that was widely distributed, then it enabled all of its other things that couldn't really be imagined at that point. Like the idea of digital sound, like I'm talking to you through a microphone that's going through a bunch of wires that's traveling halfway across, the US. coming out and then being recorded and then being distributed to everyone who listens to this, right? Like all of that is enabled by that one fundamental thing where someone just said, what if we pushed this electricity down through a tiny little wire, and it just went, wow, and replaced the light bulb. We didn't know those things were going to come. And this is similar, but bigger, right? And I think this is an example where like it's the pace of it's the takeoff pace, which I think is the most critical part of this, is the fact that they got it to happen faster and sooner than anyone really thought.
Mm-hmm.
If you're interested in it, go to the DeepMind YouTube channel, and they talked a little bit about this in some of their prior videos. And then there is a great interview with Lex Friedman with Terence Tao, who's I think he's one of the judges, or he's involved in this as well. And he said that he didn't expect this to occur so rapidly as well. Everything else in that interview, which is like 6 hours long, I didn't understand at all because they talk about these complicated math proofs. But yeah, it's pretty exciting. It's a really exciting thing.
So we mentioned last week that Grok 4 came out, and it was the first model to score 100% on the Amy.
Yeah.
Amy
benchmark, yeah.
How does that compare? Like how would something like the Amy benchmark compare to this Math Olympiad competition? And also, was Grok was Grok in this competition?
I think they had to get special permission to be considered and then submit their proofs, and then they had to organize a specific like judge on their proofs as well. So it was only OpenAI and Google, I believe, were the AI kind of competitors in there. And apparently these are incredibly challenging, and they're not just things that are like, I think the Amy benchmarks and those things have like relatively well-known solutions, and they're kind of like saturated, and it's not as challenging, it's not as hard. But also it's sort of, I'm stepping out of my lane, but from what I have read about this, it's like it's also the method of and the execution of the proof that matters. So the way the reasoning and the execution, that's another part of it, which is significant. But like it, just because it got a gold medal in this doesn't mean that it's solved, the unsolved math proofs that are out there. Like it's not like it's making new knowledge from now, but it's the fact that it has went from the silver medal level to the gold medal level in a time period that basically no one expected it to do that, which means that like you just play that out, which is like the rapid pace of change and pace of improvement across all of these applications of AI algorithmic solutions to these different types of problems, whether it's an LLM or something else, extrapolates out into some of those outcomes we were just talking about. Yeah. So that was really, really cool and exciting.
Do you want to hit on the executive orders? We can hit that very quickly, like very high level. Well, today is Thursday, July 24th. So just yesterday, the Trump administration released some executive orders related to AI. And they had 3 of them. 1 is promoting the export of the American AI technology stack. 2, accelerating federal permitting of data center infrastructure. And 3, preventing woke AI in the federal government. So 3 separate orders. And I've read through these, and I actually have some questions about, are there things that I'm misinterpreting, or what does it actually mean? But just at a high level, preventing the woke AI in the federal government, I think, is really interesting. Not really surprising at all that the administration would put something out like that. But my question is, it's the same question we've had in the modern era. It's like, how do you judge bias? I mean, that's the entire issue. So in this executive order, they're saying, they're not mandating this type of thing for the entire industry and for consumer consumption. They're just saying that if you're a provider and you want to contract with the federal government, you have to pass these guidelines, and it cannot give, they provide pretty extreme examples that have happened, characters in history that are generate images of the wrong race, things like that. But from a more business perspective, the things that catch my attention are like, if there's an infraction, the provider is on the hook for decommissioning. So we're talking about, federal contracts are major deals. That could be multi-year things. So if you're a provider, you have an infraction, they say you have to cure it within a reasonable time frame. So if you don't, you're on the hook for, I mean, millions, billions of dollars, who knows? And I don't know if there's an answer to that, but it's like, okay, we cannot decide what truth is in this country, in this world. So like, how do you even enforce that? I'm sure they'll have formal guidelines and things, but
This is
I just
super
thought
interesting.
yeah.
This is really interesting. So yeah, you're right. Like, so they're basically saying like there's a clawback component that they can do with, which makes sense if they want to kind of scare providers into aligning with the policy, which is not uncommon in a policy document like this. The fact that it says like some things in here make perfect sense. It's like truth seeking. All right, LLM shall be truthful in responding to user prompts seeking factual information or analysis. LLM shall prioritize historical accuracy, scientific inquiry, and objectivity. But the devil's in the detail here. So I wonder, for example, say if you had an education LLM that was deployed through government contracts into the education department, whatever the future of the education department actually would look like. And it was deployed in Tennessee where they're dictating that there are questions over the results of the 2020 election. Like, how would you navigate like an ideological schism within the execution of policy over the top of an LLM that needs to be ultimately truth-seeking? Like, that seems like a pretty challenging kind of bar for a software provider to meet, given that there's no consensus on very dominant, very public issues in the public domain. I can imagine, say, something like the ideological neutrality element coming into question when, perhaps issues of, say, religion come up, for example.
Yeah, exactly.
And like, this doesn't seem, this would be very, very challenging. On the flip side, also, they have a carve out specifically for, a carve out in this policy document specifically for national security applications. So you can be as ideologically driven as you want within national security or defense applications, probably because the harm prevention clause would be taken out, right? Like, so you would need to, if you're applying an AI system to weapons, then by definition, you need to be able to harm people. This is super interesting. I don't know how it's going to be executed.
Exactly.
Yeah. That's fascinating.
Where it's like, okay, I understand the general idea, but yeah, execution, I have no idea. In this, with the way that things, we all probably have ideas, but with the way that things work and are shaking out, it's like, good luck. So
I just love the title as well, Preventing Woke AI in the Federal Government. I'm like, oh, man,
yeah.
I kind of feel like they probably need to leave that word in the past, because they pretty much won. They've killed that word. Like, they've made it a dirty word. So
yeah.
I just love it. There's a lot of problems in the world. They don't have to talk about that.
Yeah,
what
so
is kind of cool?
If you're a subcontractor or contractor for the federal government, does this raise concern? Does this make you think about making your primary market someone else besides the federal government? Because I don't know. First thought, that specifically about the decommissioning, and you're on the hook for these things, that presents like major risk from a business standpoint, especially when there's if there aren't like fine guidelines and it's very clear. Seems like it's potentially a lot left up to whoever to determine. So I don't know. Just came out yesterday, so we'll see.
Yeah, sometimes these things are more of an exercise, more of a promotional exercise, right?
Right.
So we'll see where it actually gets executed. Like, I would say probably some of these things would come up against, say, like a common carrier, that common carrier defense where you can say, well, it wasn't necessarily the specific opinion or approach of the provider if you are defined as being a common carrier kind of provider on the internet. It's kind of like the defense of saying, yeah, I make the paper, but I'm not responsible for what people write on the paper. And I wonder how far into that space an AI provider could defend themselves if they came into conflict with some of these definitions around, well, that was a biased response, and say, well, actually, that's a reference to the training data. The training data says this.
Yeah, especially once the lawyers become more AI.
Yeah,
Then
that's
how do
very
you-
meta. The AI,
Yeah,
the
yeah.
AI lawyer arguing with the AI legal team
Yeah.
over the AI's output. And you're like, just put them all in an AI box for a while, and then we'll come back in a couple of
Yeah.
months and see what they come up with. Yeah, that's super fascinating. All right, did you have
Yeah.
anything else on that?
Yeah, the other ones were just what I took away from it, the accelerating federal permitting for data center infrastructure. Of course, there's a lot of talk about need for energy, need for data centers. Sounds like they're going to ease regulatory burdens for building data centers. I guess my what does this mean takeaway out of that one was using federal owned land and resources for data centers. What impact will that have? Is it good? Is it bad? Inconsequential? I don't know.
I think it's also interesting on this one, and yeah, well, specifically on this one, the only comments I have on this is that they're using some of these things as a very specific kind of tactic. So a lot of this is going into there was a lot of energy going into Pennsylvania, and because Pennsylvania has quite a lot of energy production, right? Or either existing or previously prevented, say, natural gas fracking, for example. So locating a bunch of data centers within Pennsylvania is clearly a political strategy, right? To cement that as a swing state towards the Republican Party. But on the flip side, would also provide lots of jobs and a lot of investment in that.
Yeah.
Into this domain. So it kind of makes sense. I think it's great. Like that, we need lots and lots of new data centers. Given that it was described as a log linear outcome for some of these frontier models, right? So you need to 10x your compute for a 1x output in like intelligence uplift for your next model. And apparently the next frontier models are already being trained, right? So ChatGPT 5 is about to come out. They're already training the next frontier model ahead of that, right? Mm-hmm. All of these companies are spending billions and billions of dollars on this infrastructure. Yeah, it's definitely required. What I find fascinating about this and sort of slightly hilarious is the conflicting things. So promoting, like this is obviously an initiative to try and generate more investment in the development of data centers and the attendant power needs for those. But on top of that, there are like tariff implications to importing chips that go directly into these data centers. Mm-hmm. And there's no way that a manufacturing kind of industry can be stood up around chips anytime soon in the US. Like it's just not good. It just can't happen, right?
Yeah.
It's just too complicated. So some of the things in these initiatives are great, but some of the policy decisions are kind of in direct conflict with the stated goals. Yeah.
Yeah. Which, that kind of takes us to the next one when you're talking about chips and manufacturing. The third executive order reverses the, what was it called? Advancing United States leadership and artificial intelligence. Oh, actually, that was the data center one. But the other, I guess it's related. The third one was promoting the export of the American AI technology stack. So they talk about full stack consortium applying within the next 90 days. Full stack providers can apply for government grants and things like that. So from a startup business perspective, it seems like to me this will present a lot of really great opportunities for
definitely.
But I don't know how they're defining, consortium and like, does this only apply to the big players like teaming up? Like NVIDIA and they team up with whatever else, like major provider, or do startups and smaller businesses have a shot as well? And maybe that's where the lines about the Small Business Administration, the SBA, come in. And something that caught my attention, and this is like totally out of my area, but it mentions that the SBA will provide investments into AI businesses. And I don't know, from the little bit of research I've done, the SBA has held equity in businesses, specifically technology companies, like back before the .com bust. But and I could be wrong here, so don't shoot me, but it
This has
sounds like
been talked about.
that hasn't been
Yeah.
done since the .com bust, and this potentially has the SBA providing like direct investment and
Taking an equity stake.
equity in yeah. So maybe that's
Because-
what I read. That's how I read it, and I just think if that's what it is, that's potentially super impactful.
Yeah. So it says that of this, like, so that's interesting. We'll come to that in a second. But yeah, so this AI exports program establishment where there is basically a full AI stack export package identifying what those are, which can include, it sounds a lot like software. There is like AI optimized computer hardware. So like defining products that are developed and controlled by American companies, even if they don't manufacture them, something like a NVIDIA chip stack. Then, and then also other software systems around those. So like, models and systems like, high or low level platforms. So a high level platform being something like a LangChain, data pipelines and labeling systems, and then even specific AI applications and use cases. So applied to specific use cases. But that then enables federal financing tools, as you described. So there's this mobilization of federal financing tools, and that's pretty interesting. A couple of quick thoughts on that. Yeah, so I've heard a little bit about this whole equity kind of stake component discussed by a lot of people who would be around the people in the White House. They specifically reference things like government grants that were given to, say, battery manufacturers or other kind of like car manufacturers, for example. Like all of these things where it's a form of debt financing that comes in the form of government loan in some cases, which needs to be repaid. Sometimes there's a recourse, sometimes there's a no recourse on that loan, which basically just means it's free, but you can pay us back if you choose to. All of those things have been tried. The most infamous or famous one that gets cited by a few different people I listen to is the loans that were given to Tesla, as well as other car manufacturers, and I believe Tesla was the only manufacturer to actually pay it back. So, but the arguments made is like, rather than giving $100 million loan to, say, a Tesla, why don't you just give Tesla $100 million and then take $100 million worth of stock as the federal government? Or, maybe a chunk of that is debt, and then you buy a few options or something like that. Like, so there's basically at least some sort of upside to the government investment in these programs. So that's maybe this is an execution on that, trying to say, well, let's try and take some of this AI leadership that the US has, export it, and then try and get some upside as well.
Yeah. So I don't know. Definitely presents a lot of opportunities for somebody. I just don't know who. And from what I read, it was back in the 90s. It was direct investments in venture capital firms. So it wasn't necessarily directly in the tech companies. The government had a stake in the VCs, and
right.
And then the bust happened, and who knows what the actual calculation is, but I read like $10 billion exposure in that. So I don't know. Is it the same?
Yeah. Well, they define it here at the end of this like section in this document, promoting export technology stack, section D. So basically they define it as direct loans or guarantees on loans. Then they do say, equity investments, co-financing in projects, but also things like political risk insurance, which is pretty fascinating. So
I thought that was interesting. Yes.
So say, for example, if I go in and, I don't know, sell into, I don't know, the UAE or somewhere like that, I can take out political risk insurance that potentially I might be kicked out of the country for a politically motivated reason. That's pretty interesting. I've never seen that before. And then credit guarantees and or technical assistance and a bunch of other stuff. So,
yeah,
that's awesome.
And I could be reading into it too much or just using my imagination too much. But I remember even on this show, you had mentioned, we were talking about something with, I think, DeepSeek or China. And you said, investment from the government is great, but it comes with the fact that you are beholden to the government. Does this create potentially, especially in combination with some of these other, like the anti-woke, like, I don't know, maybe I'm just overthinking.
Yeah, I don't.
But to me, I'm like,
it's definitely
risky.
It's definitely not on the same scale. Like, yeah, free, no market is ever free, right? Government is always involved, but the economic system in the US and other Western markets like Australia, where I'm from, or the UK, is predicated on the ability of entrepreneurs to actually execute independent of government, right? And make decisions and actually compete in a free market. And that's sort of the economic strength. And I think even I think that's a relatively well entrenched kind of competitive advantage in the political psyche of Western markets. When I tried to raise capital in Hong Kong in like 2016, 2017, met a few of those kind of like investors in that market. It's very different. It's a completely different way of thinking. But, capitalism under Marx has performed well. But I just wouldn't want to be in bed with those people because their DeepSeek has gone pretty quiet since it had its moment, right? And Jack Ma went missing for a bit. Yeah. All right. That's enough politics. Do you want to get into the demos, or do you have anything else you want to talk about?
Yeah. Let's do it. Do you want to start with the JSON?
I definitely
JSON
want to
mode.
start with the JSON mode. So you would have seen some of this stuff kicking off in Twitter on X. I'm never going to get over that, actually. But I thought it would be cool to highlight. So everyone knows about Veo3, the model from Google. Everyone's been playing with it. And then there has been this, I might share my entire screen for this one. There was this sort of trend of kicking off of like basically how you can better optimize the outcomes and the video generation within Veo3. So what I wanted to do was show off a couple of like a bit of the research that I did on this. And play with it a little bit and show you some of the outcomes, because it actually it's an exceptional way to get better video outputs from these video models. And it doesn't just apply to Veo3, I found. So you can actually do this with a bunch of other things, like a bunch of other video models. So you know how we were talking about, I don't know anyone who uses Grok when Grok 4 came out?
Yep.
So this is a case study where Grok excels over everyone else. So I was trying to do some research on this, and Grok just absolutely nailed it. And I think one of the reasons for that is because all of the discussion was going on X, and people were sharing examples. So it was able to get me some really, really good examples and really, really good documentation on something that was very new. So I found that excellent. If you're interested, we'll add all this stuff to the vault. So what I actually did was I wanted to go through and create a couple of examples of this. So obviously JSON is a simple kind of representation of the different component parts of the video that you might want to generate. The reason why it's effective is because it delineates, and it's super simple really in practice, is basically just delineates the components of the video that's being generated into the distinct components of cinematography, components of directed action, characters, etc. Actually, I think it's probably just a much better way for a human to think about what they want the video to be generated, So it's not just like a stream of consciousness, big block of text. But also when I was playing with it, it made me realize just how limited and how much of a wrapper some of these kind of video production tools actually really are. So it's sort of like pulling back the curtain on a bunch of these creative tools. They're really just JSON optimization products. And I'll show you an example that I vibe coded when I was going through this. So basically, the structure of these prompts is laid out here. And what I wanted to do was I went through and I basically just found all of the different examples that people on X were playing with, and all of the different potential variables that could be injected into a JSON prompt to generate a video. So we'll put this in the vault, which is our kind of resource center on the website. But you can see there's the basic stuff like the prompt and the negative prompt, all of those different components. Some of this is for different APIs, and I put all of these comments in there. But then you've got things like aspect ratio, resolution, different style, the motion strength and the style strength that you can dial up and down. And then things like the camera. So you've got the shot, the motion, the shot type. So tracking wide, the motion of the camera. You can define the angle of the camera, then lens type, frame rate, film grain, color grading. All of those variables can be injected, and all these people on X were basically finding examples or testing these things out. Then you can also define specifics around the environment, the location, and all of these things. All they do is just basically expand the universe of potential components of the actual videos, rather than like you just defining like 1 or 2 sentences. That's all it really is. But it works exceptionally well, way better than anything else that I've generated.
These are essentially configuration parameters and metadata. So rather than writing out a long block of text, you're providing the model exactly what it knows, or like the information that it tries to configure itself in the background, right? But you're basically just being very explicit, saying,
yeah, you're exactly right. It's literally just being explicit. That's all. So that's sort of what I was saying at the start, is like, it's almost like this is people just realizing that it's a better input method into the LLM from the human. Like, we were basically putting in prompts that didn't cover everything, and then we were wondering why the output was kind of crappy. So I'll show you all like the research background here. You can, we'll share that with everyone and you can go through it. But the examples is where I was really kind of like getting into it. So this is also with Grok, which is really cool. And then I just pushed each one through replicate. And then on Veo3 Veo actually released this Veo3 fast model, which is way cheaper. It's way cheaper than Veo3, and in my testing, just as good. Like, it's cheaper and it's faster. So 40 cents per second of video output, and you can play with it here. And all I was doing was just taking this JSON prompt example. So a high-speed car chase. This is this example. And here's the JSON. So it's like, here's the prompt. The configuration is 8 seconds. That's, if we worry about that. A high-speed car chase through a busy street. And then it defines the camera shot, but it also defines multiple nested camera shots, right, as it goes through the scene. So there's scene transitions that you can define through this, which is also really cool. The environment, the different characters, and then, this is the outcome, which is really cool. It's like,
I haven't tried it myself, but the results that I've seen are, it clearly works. I'm curious, Google, Gemini can watch videos, and maybe some other models. I have a hard time sometimes remembering which one can do. Is that right?
Gemini can, yeah. I haven't played with it myself, but apparently it can.
Yeah, and I've done it, but and I think OpenAI, at least one of their models, can as well. I could be wrong on that, but my point is, just like a lot of other things, I guess it's kind of like meta prompting. I wonder how well it would work if you fed a video and then said generate the JSON for this video, and then you have a pretty well defined, like, you don't even have to think about the JSON structure. Then you can repurpose that. Like, would that work, do you think?
Yeah, it probably would. Yeah, it probably would. Like, the prompts I did for these was basically like, after I did all the research on Grok, I was like, well, here are all the predefined things. Now generate me 5 JSON prompts that really push the limits of this approach, because I wanted to see like how high quality it would be. But you could just feed in, a snippet of a Tarantino film, and then say, generate a JSON prompt for a video generation model that follows the patterns of this filmmaking style, for example. You could try that. This is the coolest one, actually. So this one was like a medieval battle scene. And I've seen quite a few of these that came out that are like, they're kind of cutesy, right? They're not, I couldn't see the video that's generated in an actual TV show that I would want to watch, right? this is the first time where I put this one through, and all it is the prompt is a fierce battle between two medieval armies on a muddy field. And then it has these camera shots defined, so a wide shot, a medium shot, and a close-up. High-angle view of the entire battlefield, tracking shot following knights charging, and then an eye level of a soldier's face. Then the characters are defined too. And it's excellent. Like really, really excellent. And it also comes with all the audio and stuff as well. Like, it's just great. Like, like in the background, there's like a bunch of stuff you'd probably have to get in post, like editing, like, you know, the arrows don't make any sense and stuff. But the fact that it did the transitions, that does the characters, does the audio, like, that was really impressive. When I saw that, I was like, oh yeah, this is one, a better way to work with these tools. But number two, it's also like just way, way better results. Like, it's a better way for you to organize your creative thoughts, and it's a better way for the models to translate those creative thoughts into better outcomes. This is an example of like a surrealistic, like this one's just like surreal, crazy, like things, visual details. Like, I'll play it while you're talking.
I think it's probably significant for long form, because if you think about like a traditional storyboard, and not that I'm like a filmmaker and I know all the details of what a real storyboard looks like, but I'm sure that it encapsulates most of these things that you're defining, like in JSON, right? So
yeah,
it seems like to me this would make things like, I've said how I have an issue with generating images and videos because maybe it's my prompting, and it's like I have to do 100 iterations before I can get what I'm looking for. But this would allow you to be so much more precise in your iterations.
Well, that's a great transition. So, like, you can see it does make errors. This is an interrogation scene, like close-ups with audio. You look at their eyes. Their eyes are doing weird stuff. That's pretty funny. But I did a live test on this, but I did it with a vibe coded tool. So this is the outcome of, I basically just said, two white men walking through a busy Chinese market. They're undercover detectives stalking a suspect who is unaware that they were looking for him. Cutscenes show different angles of the scene, basically. But so this is the output of that.
You see him? Yeah, he's near the fruit stand.
Not perfect, but it's pretty good. What I actually put it through was this. So I just went into V0 and made a couple of like usable kind of tools that help you build these JSON, kind of the JSON configuration on the right hand side. So if I zoom out a bit, you see that okay?
Mm-hmm.
This is the JSON like kind of output on the right hand side that follows the all of the kind of protocol and things that are working that I found on X. And on the right hand side, there's just like variations of elements that update the JSON in real time. So you can put your kind of prompt in here. So if I just copy this prompt, and I made two versions of this. This is just there's a more complicated one and there's a simpler one. So that will just update the prompt here. And then I'll just make it like 8 seconds. And then the camera angle, like say a dolly in at like a high angle, for example. And then this is what I was saying, sort of like, now I realize a lot of these AI kind of content generation tools are really just JSON configuration wrappers with stitching. So I think it'll be a lot of fun to build one of them. And then you can just come and say, all right, here's the lighting. You can take a AI recommendation that's literally just hooked up into OpenAI. Might make it at sunrise, and the style is cinematic. The subject, yeah, you can update those. Interestingly, like this isn't hooked up correctly, so if I say AI inspired, sometimes it will contradict what's in the primary prompt. So I have to like make it self-referential. So like, for example, I had like, this is like two white men walk through a busy Chinese market, and then I was playing with this, and it turned them into like lions going across the savannah. So that didn't really work. And then you can configure the audio components, and it will update the audio components of your audio of your JSON prompt, and then you can just copy that here and then chuck it into, in this case, I'm just using replicate, but this is the playground, but you can you could just build this in via an API and then just run it.
Yeah.
While that's
Dude,
going,
that's
I'll
awesome.
show you the that's the more complicated version. The simpler version is here, which I kind of think is a bit better, which is like 3-step. And we can add this as one of the tools in the, we can add this as one of the tools in the Vault, so you can play with it. And there's heaps of these. Like, you could probably just do this with a custom GPT or something, but I kind of felt like it was nicer to put it into a little landing page. But yeah, so this is my prompt, and then like I basically chuck that in. That goes off to an OpenAI API call and converts it into components on the following page to do the export. So you've got more fine-grained control, and you're like, all right, well, this is my total high-level scene. This breaks it up into all of the components of the individual JSON file. So like, I can then go and enhance my environment component in isolation to the primary subject, the activity, those sorts of things, and then I can edit it manually if I want. Yeah, and this is just vibe coded up. So yeah, really cool. And then it also does all of the breakout for you, so it enhances it without you having to do the work. So it does the technical specs, resolution, 4K, frame rate, all of that sort of stuff. You don't have to really worry about it. And then expands all of the audio descriptions to make it all better. And then you can just get the final JSON. It also puts like the negative prompts in there as well. So I think the copy and paste thing in here was broken, but if I just manually copy it, I'll just manually copy it for now. And then come over here. Here's that version that was generated. And here's this version. Let's see what that looks like. So yeah, it's a lot of fun. It's really fun.
Dude, that's amazing. I'm stoked to use this, actually. My only problem is that you still haven't called your friends at Replicate, so I can actually use Replicate.
Well,
I'll
put a call in. I'll put a call in.
You have to pay your bill, and I've paid it. I've changed multiple cards, and I'm still locked out of Replicate. So if there's anyone out there at Replicate, hit me up, because I'd love to be able to use your products.
Oh, that's funny. That's very funny. Oh yeah,
No, seriously, Tom.
I'll
That's
put a good word in. Well, what I was gonna do is actually. Oh, sorry, you go.
No, that agents, you give agents access to this. I'm sure it would be super helpful even to agents. Maybe they can do that natively, but might help define things a little bit better and give you more visibility into what's going on to collaborate.
Well, I think what it does do, so here are all those generations. What I was actually going to do is use this technique and go back through all of because these are all my replicate generations here, but you can see the little videos from our AI intro in here that were generated. I want to go back through and regenerate a bunch of those with this technique. I think what it does is like a very simple, very fast way for you to get more control over these creative tools. It's a really simple concept, more control, and that's like the next generation that was done. It's the audio like.
The funny thing is, like you said, you kind of hit on it. It's like, well, this isn't really a new concept. How did I just now hear about this? Have people been doing this? Or it just went viral all of a sudden, and it's pretty basic, really.
Yeah. All right. That's all I've got for you on that demo. But yeah, we'll put it in the vault. You want to play with it, you can play around with it, enhance it. This will go into the build. I'll put this on the build GitHub as well.
Cool, man. Well, thank you for that. I am super excited to check that out. Maybe I'll have to find an alternative to Replicate.
Well, there's always Fowl, like fowl.com. That's a pretty good
Yeah, that's
API.
true.
API provider as well. So replicate's good, Val's great as well.
And Val, I actually set up a demo on our demo site, which is a great transition because we've made some references to like the vault and our demo sites, but we haven't really talked about it too much. So I think this is probably a good time because we have a couple neat projects in the works and at least far enough along that I think we can share it.
Yeah, that's awesome, man. So what is the vault? You're going to go through it?
So the vault was an idea inspired by Greg Camrat. Mentioned him quite a bit, and he was really impactful. Or he did a lot of work early on with the Lang chain and needle in a haystack, particularly around RAG, or retrieval-augmented generation, which we're talking about today. The build vault was an idea inspired by Greg Camrat and some others. On my screen here, you can see this is the MFM vault. It's for My First Million podcast. And so, full transparency, this was basically completely ripped off from Greg. So here's this shout out. But there's just so much you can do with this. And one of the other drivers, other than it's just kind of a cool concept, is that on this show, we aim to do demos and provide example projects and things like that. And that can be a little bit difficult to come up with test data and things that are not sensitive. Tom works with his company, I work with different clients, and we can't necessarily show that data. But since we're generating so much content with our podcast, thought that would be a great way to start accumulating some of that information and use it for demos. So we decided to set up what we're calling the build vault, and it looks very similar to the My First Million vault. And basically what this is it takes the audio from our podcast, downloads it from YouTube, and then it sends it through an entire pipeline of processing for AI. And that includes like chunking, embeddings, turning the unstructured data, the transcripts, into structured data, storing it in a database, and then being able to use that for whether it's agents that have RAG tools, or I'll show an example of an MCP server for the vault. So in a nutshell, that's really what it is. Tom, is there anything you would add to that as far as background?
No, all I would say is like this. I saw Greg's like demo of what he set up, right? And then you said you were going to have a crack at building a version for us, which is well outside of my wheelhouse. But once I actually saw how this thing works and actually the component parts of what is a very simple kind of RAG pipeline processing of like of transcripts, it's actually amazing what can be created off like a corpus of data based on what you were showing me, and how many applications there are for this kind of architecture of application, because we're obviously showing it related to the podcast, right? But the insights and the fine-grained kind of control and the components that are pulled out of all of that data, that corpus of data, really opened my mind up to like how to think about what kind of problems or what kind of things that you can do with what is a relatively simple AI-enabled application. Like,
Yep.
That's why I think this is important to show. That really, opened up my mind to what you can do with this kind of app.
Yeah, and it's not just about creating summaries of your content or things like that. To me, the power comes in with the like data enrichment, which I'll show. So we're taking the entire transcript, chunking it into small sections, using LLMs to identify, what are the actually most relevant and applicable concepts from these segments. And then from there, we're breaking it down even further by extracting things like, hey, if we talked about LangGraph, that's categorized as a product. And then on the back end, it will extract that product name and then pull additional information from the internet, whether it's, in this example, we have like images and favicons of the providers, links to their documentation, et cetera, et cetera. So let me just real quick walk through what we have so far. We have the vault. So this is basically like the raw database of insights, because that's really the primary table that this is based on. So here we have different categories. You can filter by different frameworks. We talk about, and you'll see we have a filter. It filters down. If you want, you can click on that insight. And this piece needs to be cleaned up a little bit. I actually had it more with more content and better looking. But what I think is really cool, not that I just sit here and watch myself talk, but this is if it's not obvious, this is obvious. This is like so applicable to not just YouTube videos. It's kind of a novelty example. But if you apply this to, especially I'm talking about like the product extraction, product updates, it's so applicable in so many different ways. But here you'll see I clicked on this insight and I have a timestamp. So I can click that. It'll take me directly to the video where we were talking about that barrier to entry benchmark. So go ahead.
That is like, even just that component is so powerful. So upstream and downstream from this application, so the core is basically these insights that you're extracting from the corpus of data, which is basically the transcripts that reference, say, the live video that we have. Upstream and downstream from this kind of application, you can imagine so many applications of that one simple idea. So two that immediately come to mind are, you could embed your entire product with like live user screen recording data into a mechanism like this that then extracted specific problem sets about user experience on product like that. And then you could immediately go to the timestamp and see that interaction pattern. And then you could see potentially the number of times that was done and the patterns so that's one case study. Another example is like, say, large organizations or small any kind of organization, we're constantly developing and creating just this huge amount of unstructured data through meetings and conversations, for example. Imagine all of those being funneled in a privacy sensitive way into a tool like this. So you could get every single person in the organization on the same page around, say, the way that the executive team is thinking about this strategic objective and the nuanced conversations that they've had, or how we think about a certain competitor and how we need to kind of approach how they are taking market share from us, and understand it, like basically getting that level of kind of embedded knowledge that's in people's heads that's often just described in conversations into an environment where people can interact with it, learn from it, build on it. Like, that's amazing. And it's such a simple idea.
Yeah, well, we've talked several times about the challenges with creating structured data from unstructured data. It doesn't always make sense. Like if you're talking about financials and trying to do calculations from unstructured data, probably not a very good approach. But in this example, we're not doing calculations. We're not dealing with fine, like definite numbers or anything like that. So when I say creating structured data, the structured data is more like, Tom, what you showed with the JSON. We're having the LLM read the transcript and then create that JSON object that describes, what topics were included, what products, things like that. So Yeah, so this is, I was showing, this is basically like the raw database. And I like looking at things so many different ways. So we might change that. But this is an example of the extraction, Tom. So in our YouTube videos, we provide links to the references. You know, if there's like an article we talk about, we put the link in the description. So this section called featured, it extracts those links and then it enriches that data with internet research. And this is really set up pretty basically on that. And exact same concept on products. So these are product names that were extracted from our transcripts. And the key here, and we just still have some work to do on this, but I created an approval process because you end up getting, as we all know, the AI, the LLMs, they're not perfect. So initially, I ran this pipeline and you get some junk in there. So I've also created a approval process that chunks all this up, puts it in the database. Right. So you get the idea with the products and the featured, very similar on the episodes. We have a detailed breakdown, drill into the episodes. And over here on the left, we have like key takeaways for business, technical, personal. And then each one of these tabs provides a little bit more context on that episode, where these things came from, etc.
Yeah.
So yeah, Tom, the coolest part, I'm biased because this is probably where I spent the most time on this, but the agents, you know, all we talk about is agents. We need to allow agents to have access to our, well, not always, but carefully, we need to at least let our agents have access and start building these systems for agent access. So let's show an example of like a product. So I created this button called Deep Dive. And what this does is we'll use Veo or AI Foundry. So if I click on this button that appears on the episode details, products, the featured tab, this is actually a LangGraph agent running in the background. It's a retrieval agent. So it's not set up as a general purpose agent that you would chat with necessarily. It's specifically meant to query the database and find the most relevant information. And of course, one of my favorite parts of this is the references down here at the bottom.
That's so cool, because then it's like grounding into the reference documentation or the base documentation that supports this.
Exactly. It's not as helpful if you just get this chunk of information and you're like, okay, well, I want to find out where did that fit into the conversation, or what exactly were these guys talking about? In this example, it actually didn't provide the timestamps, but let's say like, tell me about, I remember we talked about Letta. And it's actually, not to throw shade at anybody, but it's a little bit slow, and it's running on super base. So I may change that. I have some other design ideas. But here
and I push you into Vercel, and you're going to be pulling us back into Cloudflare pretty soon.
It was good. I mean, it's always good to do things outside your comfort zone, I guess. Not that it's not worlds apart different, but it's just the little things. So here you see the LLM writes a little blurb about Letta, taking from the context of our podcast, and then down here at the bottom it provides the references. So you can go to the show. This is from episode 3. We talked about that. So if I go there, or it also has the timestamps like I showed you earlier. So try to make it pretty consistent as far as controls and experience across the whole
That's so good.
The whole stack. So yeah, there's more that we could probably hit on that. But I know we're hitting close to the end of time, and I wanted to show a Jupyter notebook. I essentially took this pipeline, and
Well, actually, before we jump off that, you can actually sign up, right? So we're going to push this on the website. You can go and sign up and play with this, which is pretty cool. So go and do that if you want to play with it. If you want to talk to us about how it was built, well, talk to us, royal we. Talk to Cameron about how it's built. Then, get in touch because it's really great. Like, I think it's awesome, man. Like, I can imagine, say, a customer success team, and you could run that over all of the, say, customer interactions you've had, and then you could learn in fine-grained detail about the history of an account and go into all of the conversations and all the documentation in that way and just get up to speed really fast, for example. Like, there's so many applications of a simple product like this. It's so cool. So, yeah.
It's funny you mentioned that because I had built that before for like account management, where it's like instantaneous access to your client's information and their service tickets and things like that. And you're exactly right. Like, this is, like I said, it's a novelty idea with the YouTube videos, but if you really think about it, this is a aggregation of quite a few specialized use cases of AI, all kind of combined together into one. So yeah, we're going to continue to build on this. For now, you can access it at vault.buildaipod.com. However, we are going to consolidate it into our main website. And Tom, I don't think we've even probably mentioned the website. So you built this, but we'll have this all converged into one. So buildaipod.com is the main website for now. You can access this at Vault, and then we will have a sign up, and we're planning some cool things with content distribution and things like that. So very exciting.
Yeah, on the roadmap is definitely getting the LangChain social media ambient agent running over the top of this. So maybe I can do a demo of that once it's up and running.
Yep.
Yeah.
And that's a good point. At least in my mind, we have this basic retrieval agent, but the plan is to have, this is basically like a specialized tool and have additional agents that people can experiment with. So I'm excited about that. And then, Tom, I don't know where you're at on time, but we don't have to necessarily walk through this step by step, but
let's do it. I want to go through this. Yeah, let's check it out. So this is on the Build GitHub account. Yeah, the Build Podcast GitHub account.
Yep, and we'll put the link in the description. And what I have is I have 2 Jupyter notebooks. I'm not the biggest fan of Jupyter notebooks these days, but it is a great way to illustrate. I should have actually, and I still may, put it in like Google Colab, where it's like a hosted instance and you don't even have to download this, set it up. But that's what I have for now. So if you want to check it out, the project is Build Vault Embeddings Demo. So let me pull that up real fast. So I've already set up all the dependencies in these notebooks, so it should run straight away. But I also what I was aiming for was to add all the dependencies directly in the notebook so that you don't even need to worry about installing dependencies. If I did this right, you should be able to just open this notebook and then run it. And it will.
I think I'll be the test of that.
Yeah, let me know.
The dummy over here running a Jupyter notebook, I'm constantly breaking things, and it's like, why isn't this working? So.
Well, it's always the like default packages like pandas. You know, people a lot of the times forget to include that in the requirements because it's just everybody has that installed. So I tried to be as thorough on that as possible. Just for the sake of time, I'm not going to. If you're opening this notebook, you probably have a general understanding of packages and requirements. Yeah. So these first sections,
and just to back up,
setup.
Just to back up before you go into the configuration. So this is Jupyter Notebook demo of the embedding process from the vault that we were just talking about, where it basically is the first step, which is it gets the transcript and then puts it through some sort of process to get it into the insights output that we were just describing, right?
And actually, it might be helpful. Maybe we hit on the high-level main points. And this is not exactly
cool.
the same process. It's conceptually mirrors the same process, but with it in a notebook, I tried to make it as simple and easy to run as possible without a bunch of setup. So, for example, this notebook uses Chroma embeddings rather than the whole Supabase setup. So, just as an FYI. So, what we're doing here is downloading the audio, and that will download locally on your computer in the directory for your repo. And then we are using the LLM to extract the insights. So finding the actual relevant information, hopefully avoiding me asking just like wild, crazy questions about the metaverse or things like that. And then we're going to have the LLM review our insights. And then from there, process it even further into like summaries, products, do the link extraction. And now I may have forgot the enrichment process in here, but in the pipeline, it would do that additional internet research, validation, etc. So, yeah, just before that, if you want to run this, just set up your ENV example, and really you need, I don't know what the requirements are for a YouTube API key. I don't know if actually anybody can get that or if you have to start a channel. But if you have your YouTube API key, you just plug it in here. And then I use Assembly AI for transcriptions quite a bit. Probably secondarily, I'll use like Whisper models and through Grok. And I have different systems that I've set up. But Assembly AI is actually really, really good. So you set up your keys. Once we get to the graph piece, I've got some options for Grok and Olama. But yeah, pretty straightforward here as far as the setup, hopefully. But I guess you guys let me know. Is that true? All right, so just take a look at some of these outputs. So let me just run. I'm just going to run all of these cells. Okay, so you can see our configuration is all good. In a real environment, you'd set up much more error handling and warnings, notifications, etc. But I try to keep it pretty clean. So, and also as the example link I put in the ENV is like a 12-minute video. It's not, for this demonstration, I'm not doing like a full 2 hours. So we're a little bit limited. I just wanted to make sure that we're not overwhelming, making it too confusing.
This package,
so from go ahead.
Like this package here is like one of my most loved recent discoveries is YT-DLP. It's unreal. So yeah, like you were saying, like the API key, like you don't need an API key unless you're trying to access unlisted videos or something on a channel. But you can just configure it to grab, like as you're doing like just the audio, or like convert it into a transcript. Like you can get the full video, you can get chunks of the video. Like there's so much you can do with that package. It's unbelievable how much you can do with it.
Yeah. And you can use this with any YouTube video, like you said, unless it's unlisted or private or some restrictions. And I've already done that a few times. I even found my demonstration notebook more useful than some of the other things I'd built in the past. Yeah, so we downloaded that audio, and from that, we've got 19 segments. And that doesn't necessarily mean that those are the most valuable things. It's just that those are the most like complete chunks to build on that might contain some of the relevant information. So we download that audio, and then it confirms this is the video. Like I said, this one's like a 12-minute. It's a short video. So now we have the audio. And now...
So that's like extracting, metadata. Okay.
Yep. It would take that audio file, and you can configure different formats. I think I have it set up for WAV. We're sending that audio to Assembly AI for the extract or the transcription, and they actually have built-in tools, or like you could do some of this with their higher end products where they have like send the transcript to an LLM. It's just more expensive, and you're configuring more directly within Assembly. But okay, so from those segments, then we're extracting the insights. So this is going to be your where the LLM says, I think this is the most relevant information. And if you actually read through these, you'll notice there are quite a bit of, maybe not in this section, prompts that you need to customize if you're going to change the use case. So I actually, in an attempt to make it clean, I created a configuration file, JSON. So Tom, like very similar to what you were showing with the video as far as the JSON and configuration parameters. Here you can define like what is it exactly that we want to look out for. And so these are referenced directly in the code, but it's just I separated it out to make it more readable and easy to just kind of go and sequence like, oh, I need to change these items. So these are all things that we've basically determined are relevant to our podcast. These are known products. So I took from our database products we've already extracted. So these are the known products, website mentions, et cetera, et cetera. You get the idea there, right?
That's really cool. So it's a configuration environment you go in and build.
Yeah, or we just have these huge,
that's awesome.
Red chunks. Just ignore that. I actually didn't.
That's so good.
Yeah, and sometimes that hadn't happened before, and maybe it was a different. Oh, it's because this model. Oh, I see. I'd configured Qwen3 for the Neo4j, the GraphRAG piece, and I guess there's maybe a conflict there. So
that previous step was extracting the insights, and then this code basically generates the summary of the entire episode. Oh, that's the rendering of the insights there. Step 3. Okay, cool. If there's new products, right? So you've got a new product kind of function that puts those products in. Right. Okay.
Yeah.
Duplicate counts and mentions. So that's like if there's overlapping, there's some sort of deduplication process, right?
Yeah, exactly. And that's a good point. And I don't know how like off the top, I can't remember what I've got configured here, but in our production version, the duplicate detection is huge, because if you think about like 2 hours worth of content times, now we have like, I think there's like 20 videos total. That could grow so much. And if you hit run and you process it and it's duplicating things, it's going to cause a lot of problems. So yeah. Generally, so cool. I think what this was is like, and we can look at the database, but creating a summary of the insights. So there are a lot of different ways that you could do that, but a lot of the times a summary of each, a summary of each segment is potentially more helpful than a summary of the entire episode. And that summary of the segment or that summary of the combined insights becomes essentially metadata for the episode.
Do you think this is a mini version of like Google search? Because they do chunk up YouTube videos and they get like a component part and they'll chunk it into, say, chapters, and then they'll expose those chapters with a summary into search results so that you can actually say, I'm trying to fix my son's scooter. And I'm like, all right, how do I replace this actually happened? How do I replace the throttle? And then search for that. And then it gives me like the actual like point in the video. It's like, well, from here to here, this is like a version of how they would do that, right?
Yeah,
except they
I
do it
believe
on
so.
billions and billions of minutes a day.
Yeah, exactly. Yeah, I don't know exactly how they're doing that, but generally it's going to be very similar conceptually, at least. And then it's not really demonstrated in our vault, but think about like if you're trying to just extract what's valuable or in this data, like being able to create visualizations from these things is super valuable as well, depending on what you're looking at. So okay, so in this example, like I said, at the
embedding
very
step,
end, what was that?
Talk me through like the embedding step. I really want to understand this a bit more. So you've got all of the raw data. All of that data is then being stored, say in the production version that goes in. Those are basically just rows in a database, right? It's got the summary, all of those component parts.
Yeah, and actually, let me
What
show
do you
a little
do?
bit.
Yeah,
Like,
that'd be great. Actually, if you jump in
behind
there
the
and
scenes here.
show
So
it.
in this notebook version, we're just outputting the that process data into JSON files. So Tom, sorry, what specifically? And maybe, sorry, I don't know.
Yeah, products and segments. So so this segment is an example. Yeah, so that's what I imagined. It's like basically it's coming in and it's grabbing the components of the transcript that it's identified as the key insights, and then basically extract them into chunks with metadata. That's still the raw information. Like it's like a quote from you, a quote from me, a chunk of the conversation, whatever. It's also got the speaker identification, all that sort of stuff in there, episode ID, and the actual ID of the insight, right? So it's creating like effectively like the underlying data. And then in the production version, it's storing that in Superbase in our example.
Yeah, exactly. So instead of having this as a JSON file, we have a segments table in a database. Yep.
And then over the top of that, which is the next step in both the production version and in the Jupyter Notebook, there's this embedding step, right? And we talked about this last week. The process of like basically trying to think about like a RAG kind of process and how this is one of the first steps of that, the embedding overlay. And you mentioned something interesting last week around how like the embedding overlay doesn't necessarily have to be the whole thing. It can be the summary or it can be a component chunk of the underlying data that is being referenced, which I found that quite interesting. So it's not, you don't have to embed everything, like there's nuance around it. So yeah, I'd love for you to talk through like, well, what is this? What does it do? What's the process?
Yeah, so here you see that we're only embedding the segments and the insights. You could chunk up and embed the entire transcript, but there's also a lot of hopefully not too much fluff, but there's some like banter between us. There's pauses, things like that. So we're taking
Tom's fishing trips, all of those things.
Yeah, exactly. We're using the LLM to identify like what are the key moments, what is the actual relevant information. So we're only embedding the segments and insights. Segments is still a little bit raw, but at least it's based on like the first level of cleaned data. And then we'll be able to relate or tie that to the insights. So when we do a vector search, it's able to find like the insights, and then it can also determine what segment did that come from. And then in the background, we have like the raw transcripts and if it's in table format, then you can still pull that data even though it's not embedded, but you're using the embeddings as like for that vector similarity, like where do I generally need to look, right? Sometimes I'm not the best at like talking through all the code. I mean, it's like we could go line by line, but I don't really think that's necessary. This is kind of meant to be high level. So
I don't
Tom,
think
you just
so.
let me know what you think, like what questions pop out or what's interesting. Also, an important point when you're processing mass amounts of data, not that this is like monster data, but batching and the way that you're processing it is super important. Like this would not run as a one continuous process. I mean, maybe, but then if you have like any type of errors, there's so much when it comes to like error correction, error handling, depending what kind of system you're using. What, like if you're using your local computer, for instance, and you're chunking and processing like mass amounts of data and it's just storing it in RAM, that's not going to work. You need to have some type of batch process. And that's, last week I was talking about like traditional ETL processes. This is a good example of what I mean by that.
How do you test something like this? So, like, if I was building this, say if I was picking this up, I'm listening to this, I'm like, right, I want to apply this to an internal use case I have. And you get to this step, do you like put a summary data set through, chunk it up and do the embeddings, and then just do a manual kind of search performance query kind of like rough test? Like how do you validate that your embedding kind of ETL pipeline is good or functional?
Yeah, there are actually quite a few ways. Some probably I'm not even aware of, but we're big LangChain fans, right? So I'll show you an example where in the like production version, I have a script that will run each individual step. So I don't need to test it. I don't need to run the entire pipeline. I can run it like one step at a time and optimize it, check the efficiencies. But a lot of the times when we show LangGraph and Langsmith, we're talking about agents and LLMs. But in this case, it's all Python in the background. You still have your like document loaders and same tool sets that your agents use. So
Right.
here you have.
So you can use Langsmith to monitor this process too. Yeah. Okay. Cool.
Exactly. So here you can see like the different steps. You see like extract insights from segment group.
Right. Okay. Yeah. So if you click on one of those, like an extract insight, yeah, they're all input, and then the output, the transformation, you can see. Okay, so you've got all the same insights. It's basically just okay, cool.
Right.
I guess so you can see the performance and the results, say the embeddings in there, and there are the embedding kind of outputs, right? That's the chunk. And then the raw output on the other end, you can see. I guess the question I then have is like, how we test how usable it is. Like, I've got this active question. This is what I was talking to you about embeddings last week, and it's hard to know. Like, yeah, all right, technically the output is correct but I can't like read through a cosine table and like really know if that's like an accurate outcome that will deliver the output on a search performance for my users. And maybe there's an eval set, I'm not sure, like an eval kind of search set and a search performance ranking. Like probably there is a tool like that which you could probably use, like, because that's a pretty well-known domain, right? Like Elastic and all those guys have been playing in that game for a very long time. There's probably like a search performance tool set you could run.
Yeah. Well, that's why, I mean, we've talked about like LLM as a judge, and you're having your golden data sets to evaluate those things. So this is no different, where you could come up with a list of questions that you would ask or queries that you would ask, and you know what the right answer is. So
You just run it through.
you define that as the golden data set, and then you essentially just automate like multiple runs of it. And then you look at those outputs and you already know the correct answers generally. Like, and then you have the LLM go through and grade it and say, out of 20 runs, 10 of them were right. I mean, there are a lot of different ways, but that's exactly why I set it up through Langsmith, so that maybe we can demonstrate that here at some point.
Yeah, cool.
Yep. So, I mean, to be honest, like, this is a pretty in-depth process. Like, if you're talking about production, I'm trying to hit this really high level, but there's so much here. And this is a aggregation of like so many different concepts and things that I've done in the past. So down here at the very bottom, you can see kind of a general outline of the metadata or that JSON, how that's constructed, preview, and then the embeddings. So I don't think today is necessarily
so that's like the effective output at the end. Yeah, that's cool. And that's on the segments, which is the chunks, and then you've got the equivalent, which is the insights, right?
Yeah.
As well. Yeah, that's cool.
So that is a demonstration of the vector embeddings. There are a lot of different ways that you can do that. Again, this is not an exact mirror of what I've done in like production, but I think it's pretty simple. I've tried to make it as simple as possible to run.
That's awesome, mate.
On a
That's
similar
really cool.
note,
so yeah, are we gonna hook that up in the vault as well? People can go and play with it. Ooh, yeah, the GraphRAG one. I want you to talk me through this too.
Yeah, on the vault or demo, I think I'll put it in like Google Colab or something like that, so that you can run it in a more like hosted environment. Okay, so Tom, how much time do you have? Like, we can make this pretty quick because it's very similar. Where like, I'm not gonna go.
Yeah, I'm good, man. Yeah, I'm good. So like the reason why I think I want to, I'm keen to see this is, so last week we talked about GraphRAG over the top of regular kind of embeddings, right? And a graph database, the leading one being Neo4j, creates a kind of a graph representation of data that shows relationships between entities that may not be clearly or easily be able to be identified within a regular relational database structure. And it has specific applications. It's a well-known, well-tested, battle-tested kind of enterprise product, Neo4j. It's in production in a lot of really big companies. So yeah, I'm keen to see it because it's sort of like an interesting way. And also you were saying it's often a really effective way to get an LLM or an AI agent to traverse through a data set and understand relationships, correct?
Exactly. Like the embeddings, and that's good for like cosine similarity, semantic similarity, like putting things in generally like the same area. But a graph is tying direct relationships to nodes. You already kind of said it, but like nodes are going to be more nouns, people, place, things. Your edges are going to be the relationships. and generally are going to
Yeah.
be more like verbs. So email contains attachment, email received by, email sent from. So, and I'll show this
Yeah. And I think
example here.
say in our example, it would be like, so there's cosine similarity would place like Neo4j and Graffiti, for example, which is the memory layer built on top of Neo4j together in a cosine similarity area, similarity kind of embedding structure. Whereas you could then overlay a graph like GraphRAG over the top of it, which would then enable you to say, for example, Tom's opinion of Neo4j is X. Tom's opinion of Graffiti, the memory layer, is X. And that even though Tom isn't associated with either of those items, there's a database, like in a typical kind of cosine similarity reference, the entity of Tom as the discussion point would be a very long way away from those two things. So it's a way for you to overlay the relationships.
That's exactly right.
Do you want to share your screen and bring it back up?
Yeah. So Tom, on that last example that I plugged in, it didn't pull insights. So I'm plugging in a different example real quick, if that's okay. Because, well, while that's running, what I'll do is I'll pull up, since I've already run this, I'll pull up Neo4j.
Yeah, sounds good.
So we can show, hopefully. Tom, you were describing the graph database. We're talking through the nodes and edges. So this is, doesn't have all the nodes created because I chose a short episode, but this is an example of like what we were talking about. We have the episode, and then you can see how each node is tied together by the relationships. So, and we have the speaker diatorization. So it even has like speaker B, speaker A said this. The episode has these segments, and it was communicated by speaker A. So you can see how this becomes like a giant spider web, basically. But what
That's
this
so cool.
allows,
So it's like speaker A contributed to this segment, or speaker A and B both talked, or just speaker B talked about this. That's cool.
Right. So with embeddings, it would do your similarity search, and then it would say, what you ask for is in this general area. The difference with graph is it's going to trace the entire relationship, right? So
this is back to the Jupyter notebook.
Yeah, so this is the second notebook in the repository, labeled YouTube podcast GraphRAG with Neo4j. So it's taking that same data that we downloaded and extracted with the ChromaDB process, and it's sending it through processing to Neo4j. And part of that, the most important part, is properly defining your database structure, because the graph database is just like a relational database where you have to define the tables and the attributes and exactly how you want to structure. The amazing thing with LLMs is that you can actually generate that structure. The LLM can generate that for you. So defining all these things would actually take quite a long time. And I've done that plenty of times manually. And Neo4j actually has some really cool tools for building out your database structure. I wouldn't recommend that for, like, if you're trying to do things where you need definite, fine, analysis, you need to do it more in depth, more manually. But for things like this, like unstructured data, creating a database structure in a graph database is insane to me. And I find I get so much value out of this.
Yeah, I remember looking at Neo4j a while back, and they have their own scripting language, right, for defining these. And there's a lot of documentation and like education materials on their website about that. but you know, I can barely write SQL, so I'm not going to go and like learn a bunch of new syntax just to like use this thing. So I just threw it all into an LLM, and the outcome was great when I was using it. So yeah,
Yep.
it's definitely worth it.
Neo4j also has a MCP server that has that built in as a tool, like text to cipher. That's what their
Cipher. Yeah,
that's what their language is called.
Yeah.
So, of course, the visualizations are really cool, and you can sometimes identify or catch things that you wouldn't have just from looking at the visual. But it's not just that; it still can be used as a retrieval database, just like vectors, or just like a vector database. So that's pretty much it, Tom. I mean, at the end here, we defined the database structure and upserted these items, created nodes, edges, relationships, and then our LLM can query.
And it's a relatively simple. So if you just go down it's a relatively simple, just above there where it actually defines the schema, which has the speaker. Yeah, the relationship there, which is the whole kind of whole element is like the episode has a segment, intersegments. A segment is followed by another segment, all is connected to another segment, and then a speaker speaks in a segment, and there's only three, right?
Exactly.
So that's just the definition of this graph. You could have many other variable graphs defining relationships based on the insights you're looking for, or your intuition around relationships that may exist that you can then surface, which is another powerful thing about Neo4j, I think.
Yeah, exactly. In this example, I have it set up to completely delete the existing data and then recreate just for that specific episode. But there should be a switch you can comment out, and you could, if you were looking at like multiple different episodes and you wanted to create all the relationships for different episodes, you don't have to clear it out every time, and it would just continue and add to that existing graph that you have. So yeah, super powerful, and this could be its own. I mean, we could talk a whole day about this. So yeah, that's pretty much it, Tom. At the end here, we have, we're using, I think it was LangChain, GraphQA. Yeah, Graph Cipher QA chain. And then you can see I have questions. Which products were discussed most frequently on the podcast? Show top 10 with their mention counts. Of course, that would be useful in like a whole set of every one of our podcasts. And this is only one episode, one short video, but you can see it identified the products that we had defined, and it tells us how many times they're mentioned. And it does that by tracing through that graph. So
Yeah.
So yeah, at the end here, these are all like, once you get to this section, that's like the core process that's done. The rest of it is, these are just examples of queries that you can run. I set up examples using Local Llama and Grok with a Q.
Grok with a Q. Yeah, love Grok with a Q. Oh, that's so sick, man.
I'm a very hands-on person, so I get the most out of, like, I would have to play with this before I could even try to understand what we're talking about here. So, yeah, we talk a lot about centralizing your data in CRUD databases. There's always the famous quote by the CEO of Microsoft. These are the types of things, or the quote saying, death of the applications. So once you can get your data that you need in a centralized database, these types of things will start to replace entire application stacks. So yeah, that's pretty much it, Tom. The last thing, I'll just plug just another example of how you can do retrieval on the build vault. I created a MCP server. Can't leave here today without some type of MCP plug, but I'm excited about it for a number of reasons. And this one I had set up as it's a cloud hosted MCP server. So instead of downloading, configuring the configuration file and all this other stuff, Now you can actually use it as like a remote MCP server where all you need is the URL. And I'll put a link and instructions on that. But we've had quite a few new capabilities released in the latest version of the MCP spec. So I've built in all the newest things, including resources, prompts, even elicitations is one of the newest things. So I'll highlight this because a lot of the elicitation is where it will allow the user to provide more input before it generates the query. Like same thing as at least I compare it to, when you do like a deep research query and then it'll come back.
It's like a turn. Yeah, it's like a
exactly.
Yeah.
Exactly. Like that's essentially, at least from what I understand what that is. And I don't think a lot of MCP servers, at least the ones that I use, have these. I mean, you can see these examples, but they're pretty limited. Notion has a resource.
Yeah, okay.
Yeah. But what we've built in is like pre-made prompts and resources. So just as an example, like if I want to say find business ideas, that's essentially a pre-made prompt. And now I can be a little bit more specific. Like I want to find business ideas for financial services. And let's look for products and startups. So there, it took my input, and it's, once again, a JSON
JSON rules everything around me. Yeah. So it basically structures it, but it's querying the Vault as an MCP server. But those components are effectively kind of like skills, right? Or skills and abilities defined within the MCP server. So like you say, like all of these protocols are kind of blending into each other. It doesn't make any sense.
Yeah, we talked about skills with A2A, the agent to agent protocol. So yeah, I mean,
that's really cool, man. So like it's coming back. Yeah. So there's like effectively like endpoints and things that you defined within the MCP server for the Vault that you can then query.
Correct.
That's so sick.
And it could probably be optimized some, but so those were the resources and prompts that I showed. But the tools that if you're familiar with MCP, you're already familiar with the tools. So there are 12 tools defined here, like get products, search products. And I will also mention these two tools at the very bottom, search and fetch. Those are the requirements for the ChatGPT connectors. So you can configure this in ChatGPT Deep Research as well.
That's so cool. So then, like, for example, in that Vault, if you were to adapt that Vault example to say, like the customer success application that we were describing before, someone's trying to get an understanding of, say, a product or an account where they're at, you could then also hook up an internal MCP connector to your enterprise ChatGPT account where all of your users are to expose that data directly in their MCP as well, if they're going through that interface.
Correct. And the power, at least that I see, is composable workflows as well. So you could take this data, do your query, and then using the prompts and resources, you can engineer it a lot of different ways, but tie in additional tools and MCP servers or other and create basically automated workflows where you just click, specify some criteria, and you're off to the races. So yeah, Tom, you'll recognize these are all topics. These are all things that we've actually talked about. No hallucinations here.
Yeah, well, we have discussed some of these. I saw one up before, which might need a bit of an LLM as a judge, kind of like evaluation criteria on the transcript would be helpful. But as a proof of concept, this is amazing, man. Like, that's so cool. The fact that you could build up these AI systems and have them exposed via MCP like that, and yeah, that's really cool. So thanks for showing me that. That's awesome.
And the last piece on that, don't have really time to cover it, but there's a lot of, I've seen a lot out in the press about security issues with MCP, and it was funny. I saw one about Supabase, and I was like, oh yeah, I built this on Supabase. I wonder if if I have issues here. And at the end of the day, it all goes back to like systems thinking, because these vulnerabilities that they've described are tools that have not been set up with the proper controls in the first place. So they're like, Supabase can leak your entire database. Well, yeah, because it's configured with like as a service with service permissions rather than like public permissions, So you need to be very careful when you're dealing with these things. And it's a lot more than just like vibe coding up a MCP server that can pull data. I mean, when you're putting this in production, there's a lot more to think about.
100%. I think that's also why, when Microsoft said that they were backing the MCP standard, they also predefined a set of pre-approved secure MCP servers that they'd vetted and verified. Right? Like it is the Wild West. I guess it's kind of like anyone can build anything out there. So yeah, predefined or preset kind of MCP connectors that you use, or ones that are built properly is important. But it's such a useful tool. Like exposing this data into the place where people need the information, like giving the right context is why it's exploding, and that's also why everyone is backing it. So I think all of those problems they'll sort it out. Like the protocol will get more enterprise. There's enough of those big organizations involved, right?
Yeah, and that's really the focus today. Like authentication geared toward enterprise deployments. So we're getting there. We're getting there as far as like. Yeah, it's a lot. You see a lot of excitement, but there's still a lot to think about when you're actually deploying these things. So, but anyways, yeah, Tom, I will put this out there. So guys, we'll publicize this information, provide links, and then we'll consolidate the vault and the main website. But I'll put this MCP server out there so you can experiment with it.
Mate, that was a lot of fun. Thank you. Awesome episode. Great demos. All right. I'll talk to you next week.
Sounds good. Have a great rest of your week, Tom. Appreciate it. Like and subscribe.